And 4 or 5, like I told you, Newton's method, just disregard. We can deal with anything. I'm doing with it. I put 3 sets of learning objectives. 4, 5, what we're going to get to in 6.1, what we're going to get to in chapter 9. Meaning, this is the foundation for something you're going to come back to twice. Now, you know how the whole course is scaffolded. We use the power rule time, the quotient rule all the time, chain rule. You're going to specifically use linearization. Okay? So here's the problem from the end. Y equals tan x. X equals pi. And dx equals 5/10. What does dy equal? We don't expect an answer to that until one. But let's organize the question. I've got this H star. I have x and I have y equals tan x. And I have dy dx equals, what's the derivative of tan x? Very good, see the square. And now what we're talking about? We're talking about pi. And at pi, what's the value of the tangent? The tangent is sine over cosine. Yes? We look at the circle. We are at the point -1, 0. So sine over cosine will give you the 0. Okay? And then the question says, what's dy? Well, we don't really understand what that means in context of what the is, but we can still set up a question to organize the information. So, in the book, I think they make this unnecessarily complicated. Okay, they've got L of x. We don't need L of x. Right? It's this. It's what we've been doing. It's the equation of the tangent line. We have y take away k equals the parent, the slope, times x take away h. And then what are we doing? Well, where's the y we're putting f of x? Where does the slope we're putting a prime of x? So, let's come back to that. Here's example 1. So we're on page 234. And there's a picture on page 234 in the margin, which is helpful. Let's find the linearization. So here's the picture. So the curve is the square root of 1 plus x. What is that? That's y equals root x. Move 1 to the left. Because x is replaced by 1 plus x. Yes, I'm saying conceptually about the translation. Here you can see, here's root x, which the curve will look like. This can move 1 to the left. As you replace x with 1 plus x, so you did the opposite. You moved it 1 to the left. And the question says, at x equals 0. So at x equals 0, what we're interested in is the tangent line. So the whole section is about this tangent line, which you then do almost with exhaustion. And linearization is saying this. If delta x is small, if the change in x is small, and you travel on the tangent line instead of the curve, the height of the tangent line will be pretty close to the height of the curve. And we can use the height of the tangent line to approximate the height of the curve. So if you look at this, right, here is the picture of the red tangent line. And as you're close, if you're on the arc, if you're on the y-axis, it's tipping the curve. As you go to the right, the difference is small. The height of the red line is higher than the height of the blue curve, but not by much. And so your h, your delta x is higher. So we can take a value of this red curve and say that's going to be an overestimated magnetic curve. It's not going to be all right. Which is the origin of mathematics is not by hand, by doing linearization. So we built the table, right? What do we got? Here's our function, x, 1 plus x to the 1/2 power. So the derivative is 1/2 mu, the negative 1/2 d mu, which happens to be 1. So here's your derivative. At 0, ready? At 0, if you put 0 in the curve, you get a 1. If you put 0 in the derivative, you get 1/2. What does that mean? It means the parent graph of that red curve is y equals 1/2 x, because it's the slope. What are we doing? The graph? We're moving the picture of the book, the tangent line, that's the parent graph, 0 right to left up 1. So we get y take away 1 equals the slope of x take away 0. Now what? They want you to estimate the value of 1 square root of 1.02. So if I put 0.02 in here for x, you would get 1 and 100, which is already color coordinated in the book. That's on the red curve, 1.01. If we were then to go back and use the technology to put 1.02, I'm sorry, 0.02 in the function, you get this value. The blue value is less than the red value. Not by that one. We knew it was going to be off. Because once you travel the tangent line, away from the point of tangency, you're going to get an overestimated value of the graph. But as long as delta x is small, your value your height should not be equal. You would know that I was overestimated on this. Okay? So that's what you're doing. I'll leave that up there. And you're going to problem number 1. Okay, so for problem number 1. Here's your derivative. Here's the 0.27. There's the derivative. You put 2 in the derivative, you get 10. So 10 is the number in this box. So the parent graph of the tangent line would be y equals 10x. You're sliding through that 0.27 to the right up 7 by doing the opposite. This is fine. I don't need to put y-intercept form. This is fine. Where are you going? You're using this to evaluate 2.1. So your h, your delta x is 110. If I put 2.1 in here, you get an 8. That's the value of the tangent line. If you put 2.1 in the function, well, that's gonna, right? You're a little spoiled here. You're gonna go to your calculator. Well, if you didn't have a calculator, cubic 2.1, then subtracting double 2.1 out of 3 would take you a little bit of that. Whereas here, using the tangent line, you're off by 61 thousandths. You need to look at this. You need to cross-reference your work you have in front of you, what's up there. I'm going to go around the room and see anyone who is missing in each room. We don't need people to go rogue. Now keep this in mind. These are user-friendly questions. When you get to the word challenge problem, that's the point. You want to have some technique you can rely on to do this. Example 2. So example 2 is about the cosine. There's a picture in the book. There's the cosine wave on the page, 234 at the bottom. Here comes the wave. Okay? And they're saying, let's use this to approximate the cosine of 1.75. So you don't have a calculator. You can't type in your phone screen, cosine of 1.75 radians. You want an estimated value. Okay. So to do that problem, we would say, here's the parent graph, the cosine. The derivative is a negative sign. They tell you where to start. They say use the value of pi over 2 to approximate 1.75. So if I put pi over 2 in here into the cosine, pi over 2, we get a 0. The sign would be your 1, so negative sign would be the negative 1. So the parent of the tangent graph is y equals negative x. We have to slide it. This is the magnitude of the slide. Pi over 2 to the right of 0. You get this. So to approximate 1.75, we put 1.75 for our x. Don't give us the approximate y. So we estimated pi over 2 to 3 decimal places. We're saying y equals negative 1.79. In the picture of your book, that's on the red tangent line. On the blue graph, if you did this on your home screen, what is the cosine of 1.75? You get this. You're off by 1 10,000. Okay, if the delta, if the change is less than 1,800, you go by less than that. So that's up there, that's your model. You're going to problem 5. So problem 5. You have a tangent, remember the tangent secant squared. Goes on the square. At pi, the tangent is 0, which we're going to use to do the problem again. Secant squared gives you 1. So what we have? The tangent line has a free image of y equals x. And you're sliding pi would right up 0. So you would have y equals 1 times x take away pi. Delta x is 1/10. You have 1 times 1/10. That's on the line. That's on the tangent line. If we put pi plus 1/10 into the tangent function of your calculator, we spit out this. So how much are we off by? 3 10,000ths. You need to do this, right? Because this comes back up twice. It comes back up to the BC children when we do Euler in chapter 6.1. It's not an AB top. When we do chapter 9, it's not only AB top. But this technique's going to come back to you. You want to have this, you have this approach. And the approach is, you have the T-chart, the H-chart. I do the template for the tangent line, and you compare the outcome of the curve with the outcome of the tangent. Right. So, if you are at home, you are dismissed, do the exercise. Now, this is one thing very specific. In the event you are ADV, which is, so that's it for 4 fun.